Well, we got a time slot here for the the artist formerly known as Kit, who, after his fantastic presentation earlier, we're going to take this time to open it up a little bit and have a little bit of a mini Zymposium, a little bit of a panel discussion. One of the things I thought was really great yesterday was getting feedback from people who were using Zio. And so like Jan, working with Akka Streams and Zio, had some very specific actionable feedback about things that he felt like, well, maybe this could be done a little better. And actually, even yesterday, we merged a pull request to implement one of the features that he talked about there. So I think that's always good and we can get it remotely, but it's even better when we're together in person or we're at a venue like this. So we thought we'd use this as an opportunity to hear from you, and we'll try to both pass the microphones around the room as well as use Discord for people who are here remotely. But we'd love to hear maybe initially just 1 or 2 minutes from people on your thoughts about either this is great, I want more graphs, more Mermaid, or this thing is not working for me, this is not clear for me, or this thing is easier for me in another framework. And then we can build from there, and depending on how active you are with your thoughts or questions, we can just kind of fill the time with that, or we've got some things in the works if we need to, if people are a little more quiet. But yeah, let me start with, is there anyone in the room here who'd like to share some thoughts about their experience? Yes.
Guys, handheld one, please. Hi there. So I really like what's going on with Zero 2 with Z layers, because Z layers is good in terms of the the graph and so on it constructs, but it can be a bit clunky to actually swap out dependencies, for example. So when you're doing tests and you do something like, okay, well, at the test scope, I've got a bunch of dependencies which are shared. Individual tests, you might want to say, I'll swap one out. So you do something like provide some, but then you've got to provide all the types that you've got to swap out. So I wondered what impact the changes for 2 have, and whether there's an easier way to sort of target the type that you're trying to swap out, rather than explain all the other types that you don't want to swap out, which is ergonomically not so good. And the second quick question, if there is time, could you sort of explain what these spooky phantom types are and the general mechanism, because we haven't covered it as far as I know, and that would be fascinating if you do have time.
Yeah,
sure.
Yeah, totally. Could we share the old screen on the big thing, and hopefully it works this time? Before I flip around, we have a backup now, but
Yay.
hopefully I quit a lot of stuff in the background. So yeah, that's a great question. But first, so yeah, there are 2 parts, right? So the one was like ergonomics for providing partial layer dependencies, right? And then secondly, it's sort of about how the heck phantom parameters. So yeah, that would be great to talk about phantom types and how they work. Because yeah, as Alex Yaffe mentioned the other day, they sound scarier and spectral than they actually are. They're quite simple. But yeah, so first with the ergonomics for partial layer, that is, let's first sort of outline the issues. So I'm going to make a simple Zio effect that maybe needs a service, and I'll zip this like it needs an int and a string. We'll just keep it very basic. You probably wouldn't provide these as services, but you could wrap them in case classes. But for now, let's just do this. So this is going to get us a Zio effect that's that's
A little too fancy with Copilot.
Yeah. So this is going to get us back a tuple of an int and a string. So calling zip on, did I do this right? No, almost. There we go. So this is going to add these dependencies, right? So this service, as we know, needs an int and will get us back an int. This one will get us a string if we have a string in the environment. So they're just both that sort of like environment identity method. And then by zipping them together, the cool thing about Zeos is that they compose not only, well, this will compose the outputs as a tuple, but it'll compose the environments using the intersection type. So it'll zip them together. And that's kind of why, one of the reasons we use the intersection type. It's because it's sort of commutative. You can flip the order, it doesn't matter, it's still going to compile. As we nest these more and more, as we add other dependencies, if I also zip onto this a service of a Boolean, this is going to be flattened in ZO2, by the way. And it'll also, I can put the Boolean in the middle. It doesn't really matter. It's all the same. So this is tracking everything we need. This is tracking what we're going to return. So one of the problems could be that we want to provide just an integer or just a Boolean, because if we want to run this, right, and we sort of want to make it so that we've provided the environment, we've called the environment, we would call, provided here. I could say example.provide, and it's going to prompt me, hopefully, that, yeah, I need a string, a Boolean, and an int. And Adam down here, I'll make this lazy so I could do this in a random order. I could provide an int layer, which is great, and now I just need a string and a Boolean. So let's see if Copilot can, lazy val string layer. Come on, you could do it. Yeah, and then it's probably going to figure out the Boolean layer. Yes, Copilot, lovely. So what if I just wanted to provide the int layer here, though? What could I do? Well, one thing you could do is call provide sum, but there's a nice error message for this, I believe. Oh, well, yeah, it actually, I need to improve that. It's saying I still need to provide 2 layers. But basically, if I don't want to do this, what I can do is you have to provide the remainder, which is not the ideal experience, right? This is kind of an issue. So I can say, well, you kind of have to do this mental set math in your head. You've got to do the set difference operator in your head, know that, okay, well, I started with this, now I need to subtract what I provided and provide the remainder. Oh, sorry, let me just comment that out real quick so I could recompile. And we'll see that this actually works now. And the type of this is going to be, well, the remainder is required, but we've provided just the int layer. So that'll work. But it's not ideal because you need to provide that type description. And in a perfect world, the Scala compiler would infer set differences on these intersection types. That would be amazing. Unfortunately, it doesn't always work that way. Unless, and Adam and I and others have experimented with this and wasted so many hours trying to in Scala, a good tip in general is if you think something can work, and it doesn't work the first time, try to write it in literally every way you can imagine. Like switch the order of the type parameters, move it to a different file, try it as an implicit extension method. Do all those in combinations, like combinatorically explore every possible variant of providing something. And one way that it turns out it can work, I think actually Alex Yaffe first discovered this, is that if you have the layer on the left-hand side and the effect on the right-hand side, that allows Scala to infer, it nails down the type parameter of what you're providing first, and that allows it to do the set difference for us. So this is fully inferable. If we made an operation on Zio called provide, which will provide this layer to the effect. So you kind of need to flip it around and go the other way. And so this works the same as this, except you don't need to provide it. So that's kind of a new thing that we added, which is a little nicer. It's awkward, unfortunately, that it needs to be different, and it can't just fully infer this. That is currently a limitation of just how the Scala type system infers things. And let me just sort of quickly go over that. So, oh yeah, and there's another way of doing it, which is basically we added an apply method to layers. So instead of doing zio.provide, you can also just literally do the layer.apply, and it will provide just that layer to the effect. So it's a little better than nothing, but it's not perfect yet. And this provide yet is not macroified. So if this needed some transitive dependencies, if this int layer, say, needed a double, it would not help us right now here. But that could be macroified. It's just that this is sort of a recent thing that we added, so that's not doing it yet. But theoretically, that could be possible. So that's one nice sort of thing. Does that answer sort of your first question as a potential thing? It's not ideal yet, ergonomically speaking. It would be great if this just kind of inferred, or there could be some other variant that would infer it here. but it's kind of the best we can do at the moment. Maybe we could open up a SIP and ask Odersky for his help here. It's a pretty Zio-specific issue, but it is definitely, I'd say, like the remaining non-ideal point. So I'm very glad you brought that up. But some tips, I guess, would be just to put this type here. I think in the macro, what I can do is, I don't think I've done this in Scala 3 yet, but in Scala 2, if you do not provide a type here, it will recognize in Scala 2 that this will basically, that type will be inferred as nothing automatically if you don't provide a parameter here, because it's not attached to anything. It's kind of a phantom, well, it's not a phantom type. We'll get to phantom types in a moment anyway. But it's attached to nothing, so it sort of just infers as, all right, we're nothing. But the macro will then see, is that type nothing? And if it is, it'll put out a warning message that says basically, hey, make sure you parameterize this, and it shows an example, and it's all syntax highlighted, and it's like, please parameterize it with the remainder, and it explains sort of the concept that I just explained. But theoretically, it could also then print out in the error message, and here's what the remainder currently is. Copy paste this if you would like. I think that would be possible. Yeah, that would be possible. So that could actually be, I'll make a little to-do for myself. Let's do that. Do the thing I just talked about. And that'll be enough to remind me, and I'll misspell it. Perfect. Okay, so anything you'd like to add to that? Thank you for the examples.
No. Well, I think the one thing is this is something else that was enabled by eliminating has from the environment, because this is something we've been working on for, like you said, probably a better part of a year, kind of trying to be able to do this partial elimination, and we couldn't get it working across Scala versions with having has, but now we can do it in these two ways, and Kit's 100% right. It's not quite the perfect way we would like, but I think between the two of these, and particularly this, I think, way where you can view each layer as just eliminating that part of the environment that it provides, it's definitely a significant step forward there.
There is also a nicer thing to do, a slight change to just layer, partial layer application. And so one thing that can actually often happen, I'll just have some, let's have some case class, some service. Let's see, foo live, right? And we'll have a trait, foo trait, that'll just have a method, obviously, bar, that will return an int. Okay, so this will extend a foo, and it will do something. Let's say this is sort of like an in-memory representation, so we'll probably have a ref of something. So maybe we'll have a ref of an int, and this is just going to call this here. And we might also have some other dependencies, right? So maybe it's we have our logging trait from before. I think analytics, right? I think analytics still exists, so we'll throw analytics in here in this project, right? So, and I'm just going to delete these things down here because we're not quite talking about that right now. Okay, so just get it compiling, good. So we have this, right? So we can, inside of our foo, object foo, we can make a val live, and I could say foo live dot apply dot toLayer. And what this is going to get us is it's going to lift that constructor, and it's going to, if I can insert type annotation. Am I screwing this up? Foo live dot apply dot toLayer. This just might be IntelliJ being weird. Let me see if it knows behind the scenes. Am I screwing something up? Yeah, it knows what it needs. It's just that VS Code is failing me here. Okay, so this is going to be a layer from. It's a little long here, but it needs a ref of an int, right? It needs analytics, and it needs a ref of an int. Oh, thank you, Adam. And so on and so forth. And it'll get us back a foo live here, which if we wanted to, we can widen to just foo or what have you. Even though it doesn't matter if it's foo live, that works as well. Foo, and what? Why is it sad down here? Oh, because this needs a something. A colon. A colon. Thank you, audience. Perfect.
Yeah.
So what is kind of weird about this is that it's nice to use this toLayer on the apply, but we don't really want to leave the ref of int as a pluggable piece, right? We probably just want to make the ref of int right away, which means that, okay, does this mean we have to write it in this sort of more verbose way, which is not the end of the world. But if we did want to do this, we could make a new ref of an int. We could grab our analytics service out of the environment by doing zio.service of analytics, and then we could wrap this all in the layer.apply as well. That basically is the same as chaining.toLayer. So you have a couple ways of doing this, and then we would return just that thing, right? Foo live of ref analytics, which You're better than Copilot, Adam. For now. We'll see. So, yeah, and it's kind of annoying that now we need to switch back to this old place just because we wanted to provide this ref here. But we sort of did something different in ZO2. We changed the way that the provide operator works for combining these layers. And if you remember this compose operator, if you have a layer that goes from A to B, and you have a layer that just sort of goes from anything to A, this will eliminate that dependency. So it'll provide this output to this input. In the past, if this also, let's say, needed A and B and went to C, you would need to provide everything. You would need a layer that provided the full input. Now, because of those changes, it's able to eliminate. And so this will actually get you back a new layer of just the leftovers. So just B to C, because we provided a layer of A. So with that, oh, yay! But where it's sort of like you can add it together and it becomes nice to make things simple is now we can go back to foo_live.apply.toLayer. And I should mention that only in Scala 3 that works. In Scala 2, you can do this. This will work across versions. And in Scala 2, you can actually just do this. But they took that away. It's too nice. So let's go back to this. So now, instead of doing this, we want to eliminate just the ref events. So what if we did the following? What if we'd say ref.make, and I could do 0, and then I could do this? Oh, and then I have to turn this into a layer, 2-layer, right? Because that's a Z effect, and that works. So we can have a layer that we can just sort of make it, we could extract this into its own ZO effect or whatever, and provide just some of this. So now as we add, and this fully type infers as well, so as we add other dependencies to this implementation, we can just provide some of it here and leave some exposed to be swapped in later in your different sort of provide calls. So I'm happy about that. That's kind of like a little bonus to the ergonomics there. But I think that's kind of what we did to sort of help with the provide some problem. Yeah, and there's probably, if anyone has other ideas or wants to experiment, there's probably more we can do there. But it is sort of it can drive you insane. It can make you mad. But yeah, the second part was phantom types. Do you want to talk about phantom types?
Yeah, absolutely. So I think the simple way to think about it is it's just a type that we're never going to actually create a value of that type. So if we go back to, maybe if I can Control Z and we can go back to one of our examples here, I'm very slowly. So even that kind of gives me what I need. So here we've got this layer that requires, say, a ref and an analytic service, or maybe produces a ref and an analytic service. And that and it's a nice Scala 3 thing, but really that's with. That's conceptually that's saying there's one type that is both a ref and an analytic service, which is not actually a type we can ever create, because this ref is this one like sealed data type that like you can have a ref of an int or a ref of a string, but it's like one specific type that like has a set of methods on it. And this analytic service is like a totally different interface. And there's no way that we're actually going to make one type that is both a ref of int and an analytic service. There's no one thing you can ever point to that is both of those things. So in a way, that type is a little bit of a fiction of there's no one thing that is X and Y that we're ever going to create. But it's still a pretty useful indicator for us of we can look at that and we can say, and sometimes maybe it is easier if we use the and versus the with, that this is something that requires a ref and an analytic service, or this is something that produces a ref and an analytic service. So that's really what it just means to be a phantom type. It means that we're using these types to convey this information, in this case, which services we need, but that we're never instantiating that exact type that we're using in that signature there.
Yes, so one potential example of this, if we wanted to, this is kind of what it means to be a phantom type. If you have a parameter that exists in the type ascription, right here in this case class, we have this R to make it similar to what we're talking about here, but it will not appear anywhere internally, or at least not we're in a value here, right? We don't have a set of R, we have a set of any here. The R is just used at compile time. It's just tracked by the compiler, and one cool thing when you do these phantom types is that you can use them in macros. So we can take this and type, this intersection type, and we can, at compile time, break it apart into its components. So we can break it apart along the and basically get a list of the different types that you need, and then do these graph traversals on them, these set differences. the sorts of things that Lander was showing before, and those graph things. So it can be very useful for that, and we can also use them in type constraints. So you have to provide a layer that has this R, or at least this R, or something like this. And we know, and it can help us sort of, if we limit the ways of constructing these things, if we make it correct by construction, we can make, if we know that there is a particular R type, that can tell us that the user must have created it with certain constructors. So we can make certain assumptions about what's inside of it, if it's meaningful. Like, this is just a set of any, but these types of R, we might, because you can't have a set of multiple types, it has to be one type. So we would lose type information. It would basically become any if we put an int and a string in here, or any object or something. But if this were an intersection type, we can AND them together and sort of track what's inside. So if on object box we had an apply method, we can take some R, and we can take some value of type R, and we can get back a box of R just by putting the value inside of the box, right? This is kind of a lie that R could be anything. I could put int here. Like, it is not constrained by the implementation because it's not used internally, so it doesn't matter. But if I do R here, then I can make another plus plus operator on another box of R1, which is a more narrow version of the box. And I could take that box of R1, and then we'll return a box of R1, and I can just zip the sets together. And already we can see that the val int box equals a box of 1, val string box equals a box of foo, and then val both boxes, like, let's look at the types. This is a box of any. That's not true, I think. And if I ascribe this to int, it'll say, oh no, it does say box of any. Because, shouldn't that be apply box? Maybe I'm going to say box make. Maybe it's doing the wrong one. And either way, this definitely works in general, so I'm not sure if it's just the live coding curse. It says box of any, which is weird, right? Does that seem, am I doing something terrible here? Maybe I should make this, no, I need to have this be that. That should definitely figure it out, because I'm telling it that it should be a value of type R, and I'm making a box of R. Maybe I should do box of R here. Are you just silly? Whatever. Let's just pretend that it's working. It should be doing this, and this is how Zio works. So I know this works in general. And then this, hopefully, will be a box of int and string, right? So we're tracking what's inside the box, even though this is a meaningless type. But because we've limited the way the constructors work, and we can use this sort of this narrowing annotation, which will, when the type is contravariant, use the AND types to join them together. So if I keep doing this, we'll keep getting a bool box, plus plus bool box. We'll get back a box of int and string and boolean, which is useful. And it actually tells us something, because we know what's in the box. So we can make like a get method on our box, def get, some type that is, a subtype of R, which I don't think I need this. And then we can sort of try to get that type out. Well, we have no way of accessing this set currently, actually. Maybe we could do some sort of filter if type is or something, or find dot is instance of R1. Will that work? I'm not sure. Let's see what this even does. This may not work. And then I'll just call get, right? Because theoretically this should work. Nope, not happy. R1 is a type, R1, any, found any. I know, as instance of R1, because we know that should be true, technically, at this point. I don't know if this is going to work. Let's see, print line, both boxes dot get an int. Can we get an int out of here? Does not confirm to the upper bound. Did I do it backwards? Should be R is a subtype of R1, I think. Oh, R1. Let's just do R1. Okay, and that worked. We got the int out there. Maybe I could do implicit evidence that R1 is a subtype of R, or maybe I need to flip it around. No, other way around.
You want to be a super type, yeah.
Let's go their way. Okay. Covariant type R. Okay, fun times.
Well,
oh, like this? It's hard to give up. Okay, yeah, I give up. But generally, that's how it works with the has, and you can do these fun things. I've not been able to get that to work there, but that's basically what we're doing. Imagine that worked, and that's because it doesn't if you type it differently, and that's kind of what we're doing. We're just tracking information at the type level that's not actually represented at any value, except it kind of is. But we have to maintain that truth in our heads. The compiler isn't going to. We just have to make sure we code it correctly. So it's like a fancy advanced implementation technique. Does that make sense?
I've got one question just around how you're introducing the box
Mm-hmm.
for the call sites there. So it makes sense around phantom types, but then when you use them with a with operator, if you like, in the environment, how are the boxes appearing?
Like if we go to ZLayer, this is kind of a phantom type in the same way. So it's sort of just, it's kind of all hard-coded together. So when you make a ZLayer that needs something, it'll put that type there based on how you construct it. So same thing with the ZO. So if I go to zo.service, right, def service, you give it some type. You just instantiate it with some type, and it will take that type and make it the environment type. And there are some constraints, and there's some other implementations, and it's silliness to make it convenient to work with and to let us actually access these things at compile time in a safe way using these tags, and there's a whole bunch of details. But it's basically, at the end of the day, just a phantom type parameter. And we're doing the same thing of like when we zip them together. If I go to def zip, we're getting another environment that is a subtype of R, and it's going to basically with those environments together and keep going. And it does this for zip, it does it for map, it does it for flat map, and et cetera. Every time you compose ZO effects together, it's going to keep accumulating all the environments used and inferring this automatically. So that's kind of how you get away with not annotating types. And yeah, we probably should do a longer thing at some other point.
That was a very comprehensive answer there. Maybe I think we have one more question in the back there. Yeah.
My question was on the inference of the remainder in the previous example. Mm-hmm. The fact that you can't do that is because of compatibility with Scala 2 or purely on Scala 3?
So it doesn't actually work in either, and you can trick yourself that it works because it actually looks like it compiles in IntelliJ. And if you ascribe the type, it'll compile, but it does not infer correctly. It doesn't remove it automatically for you unless you ascribe it manually, which is kind of defeats the purpose of just having it type infer. So yeah, I tried to write that in lots of ways, but if you sort of have A and B, and then you try to subtract B from that, it doesn't work. But if you have B, and then you say subtract this B from this A and B, it works. Don't know why, but some implementation of the compiler and just the way it resolves these things. And it doesn't work for either 2 or 3 at the moment. But there may be some other way, and I've tried it in lots of ways, but there may be
I think I have a way that I'll show today at 4 o'clock, but I'm not sure if it has the same trouble of yours.
Okay.
So let's catch up later. If that works, I'll contribute it.
Whoever figures that out gets a chocolate bar. Please, yes, open bounty on the head of being able to subtract and provide some. Everyone, go crazy like us on that problem. All
right. Well,
yeah.
I think we're probably about at time here. So thank you so much, everyone. I'm sure I know there were questions we didn't get a chance to get to, so we'll either do another Zymposium, not at a conference to go over those, or we can follow up on some of them on Discord. But thank you so much, everyone.
Yeah, thank you.